Hello and welcome back, guys. So in this video what I will do is I'll show you I'll tell you what NAT is. Okay, NAT. Okay, so the full form is network. Let's just close this thing. Network address translation. Okay, so this is what we will be doing, network address translation. So how many type of NAT are there is that one is static and second we have is dynamic. So static is always fixed, right? Dynamic is whatever is available will be used, right? And then third also one that we will be looking at is PAT or NAT overloaded. Okay, so this will be based on the port. Alright, so first thing first, let's look at static. Oops. Okay, so whenever we are looking at static, talking about static, what happens is that, so suppose this is your router, this is your ISP, and you have a connection coming in, right? And then you have like another router over here, and then here is your LAN, right? So what happens is basically whenever you are using a static IP, what you do is you basically request as a company to ISP for a public IP, right? So what happens, like what kind of public IP do they give? They might give us like IP which is like basically 179.182.1.0/24. They might give us the whole block if it is available, of course, right? If it is available. Otherwise they might just give us like, they might do their own VLSM. They might also buy it from INA and from its regional office. Okay, so they might buy it from a regional office of INA, and then whatever block they might have, a list of IP, they might just do VLSM and then give us the IP. Okay, so what we do, we use one IP over here. So since .1 will be our network ID, that might be used for network, and then .255 will be our broadcast, right? So the rest of the IP we might be using it. So you might put one IP over here. Let's go .0 is our network ID, 1 is used over here, 2 over here, and then let's go like 3 somewhere around over here, 4, and then there on you have like so many LAN connections, 5, 6, all the way to 200, right? So you might be using it in this way. So what happens is that, so whenever you make a request from here, so what happens is so you will already have a public IP address, right? So if you have a server over here, what happens is, so this is your server, so you will be providing the outside world. So suppose you are a user over here in your home, okay, and this is your LAN, so you have a PC over here, and then from where you are requesting, so your IP is 192.168.1.1, right? And then you're requesting some kind of information. What happens is it goes to your ISP, and then ISP knows that like this is fixed, right? This is very static. So after that what you do is you browse this particular site or whatever, and then your traffic goes all the way over here and then comes to your server, and then the information again flows back like this, right? So what happens is, so there is a public key over here, public IP over here on your router, on the exit port of it. And then what happens is, so when you send a request, it gets translated over here, and then after that your router will make it a public IP address, which will be provided to you by the ISP, right? You won't have a static IP if you have not purchased it. And then what happens is, so the traffic will go to ISP, and then again ISP will basically forward it. It will look at its routing table, and then after that it will send the traffic to the server that's within our LAN, right? Within our LAN premises. So during this process, what happens is everything is static. Okay, everything is static, everything is already defined. So this router will have a default routing table, and then it will basically be sending information to ISP, and then ISP will definitely send the information to our respective server. Okay, so this is how it will work. So it's static. Fixed, all right. It's fixed. Give me a second. In this case, what might happen is that so you're the only one, like who has a fixed IP. Okay, so this person over here, it might not have it. So see, it's 192.168.1.1, right? So this is like inside address. Okay, this is inside a LAN, and then what happens is, so basically a request is sent from here, and what will be the source IP? Will be 192.168 blah blah blah, right? And then it comes to this particular router, and then after that it translates it. Okay, it translates it into a public IP, and then only it flows outside. Okay, and then again, so you see over here the LAN might have different PC over here as well, right? So what might have happened is that, so they might basically be doing something like this. So the traffic flows all the way from here, it comes to this router, and then in from here. And then what they might also do is they might map particular public IP. Okay, so they won't definitely assign all this IP address like this. Okay, so you might be thinking in your head like this is the way, that's how it is done, right? But it's not done like that. See what happens is, all the traffic comes over here, and then you might have your own LAN over here where you might use something like this kind of IP in your own address as well. Okay, so like suppose the traffic is entering from here. Okay, so I'm just drawing only this much things. Okay, ISP, and then you have your LAN over here, right? And then you have your LAN over here. So you have different PCs over here. So what you will do is you will have a net table. Okay, net table. In that, what you will do is, inside this router, what you will have is, you will have a different network. You might have 192.168.1.0 network, right? So you might have different PCs over here. So what you will do is, it will have a private and public. Okay, so you will be mapping these two things together. So when a request is sent by a user from a LAN, it comes to the public address until the router over here, and then that router, it basically translates it into a private IP and then sends it inside. Okay, for the respective particular system that it is looking for. Okay, so it might be looking for 8888, and then so you might have like 8888, that's your public IP, right? And then inside this Google's thing as well, they might have a local LAN area over there which might not use this particular public IP. They might not use, because hackers might basically attack the system, right, directly. So they might need to use a net and then redirect it inside the network. Okay, so in this case, what they will do is, what's the private IP? So you might have like 192.168.1.1, 1.2. So you might basically, they might link it to the public IP that they have bought. Okay, 888.9. so suppose they have like a block with them, 888.1.1, 0, let's say, right? So they might have like let's go 24, right? They might have the whole block with them, okay, which they have purchased from the ISP purchased, okay. So they might have purchased it. So who does the ISP purchase it? They purchase it from INA, that is also from the regional office, okay. They have a different regional office which sell it, okay. And then what you will do is, while you are sitting on this particular router, you will have a netting table. In that you will basically map two addresses together, the private address with the public address, okay. Similarly you might have 888.10. So suppose if a PC over here, PC pings let's say 888.9, right? It is pinging that particular router, but what happens when the traffic comes to this particular router, it gets translated again, okay. So this IP address will be translated to 192.168.1.2, and then only the traffic will be forwarded to that particular system. It might be mail server, it might be anything else, okay. So it might be different things. So let's not only say server, but like let's say like a PC, okay. So an outside user might be actually wanting to access some resources that is within this enterprise, okay. So this is how it happens in a static case. So what happens in a dynamic case? So in a dynamic scenario, whenever we are talking about dynamics, so the name itself is very explanatory, right? The name itself is explanatory. What happens is, so you have a router over here, you have a two router over here, there is a LAN over here, and there is a LAN, okay. So what happens is, and you have an ISP in the middle, right? ISP, this is your Soho, this is your, I don't know, XYZ enterprise, right? So you want to access a system over here. So what happens is that, so this is a Soho environment kind of example, okay, that I'm particularly giving it to you. So in this kind of environment, what will happen? Your thingy will have, your LAN, your system will have some kind of IP, like let's say 192.168.1.1, right? So this is your PC's IP address. The traffic flows through all the way from here, goes to the router, and then there what happens? A NAT, right? So it gets translated to a public IP, and then what kind of IP does it take with it? It might have like 172.168.2.9, 172.168.3.5, and then 192.168.1.1, 1.2. So suppose this address is not available, then the traffic will take this particular IP and then go to the other part of the world or wherever you are trying to access, okay. So if this is available, so whichever is available, the first IP whichever is available, that will be used, okay. So what happens when you do this? What's the problem then? When you're doing this kind of stuff, what happens is that so this is a dynamic IP, right? So the IP is generated, or it changes frequently, okay. That's the main problem with this kind of stuff. So if the IP is changing every time, so suppose you have suppose if you use this in an enterprise, so suppose this is an enterprise, right? And then you are a PC over here trying to access all the way from here all the way to this particular system that is on this particular LAN, right? So what happens? Every time you're trying to ping it, the IP is changing constantly, right? The IP of that particular address, particular system is changing constantly. So how can you be like within 1 hour the router restarts, it's a different IP? So that's not very good, right? That's not very good, or that's not even possible, like to comprehend like how many IPs is generated and how many IPs is being used, right? So what happens in this kind of scenario? Dynamic is not the best in this kind of particular scenario that I'm talking about. Whereas in a Soho environment, is it is the user concerned about like someone accessing their PC? No, they only want a connection to the external world, right? So it depends on the scenario as well, okay, whether you want to do a static NAT or dynamic NAT. It just depends on the scenario. Everything is based on topology. Everything is based on topology. I repeat, everything is based on topology, okay? So the problem with this thing is, suppose you have external system which wants to ping it to it, and then what happens is that basically your source IP will be changing every time. And then if an external system wants to, let's say, access something over here, right? So suppose this might not be the only enterprise, so there might be another thingy that might want to exchange, let's say, like connect to your system over here. What happens? So you might see your IP and then give that particular person, okay, this is my IP, you can ping it. And then you start pinging it, and then a day or two later, or like within 1 day, how much ever the lease time of that a lease is, like you get a particular IP for a lease period, okay? So in TCP IP, from DHCP server, and then what happens is it assigns you with the lease. So it might vary with within hour, within minutes, okay? So how much ever the lease time is, you will have that particular IP. But it's like it keeps on changing, right? So it's not very efficient, like for both way communication, okay? So in this scenario it's not very good, okay? But understand the concept. Whichever IP is available, it takes that IP and then it goes to WAN. WAN, okay, it goes to WAN. That's pretty much it. All right. So similarly, if we were to talk about, let's talk about this guy as well. The third thing that we are going to talk about is PAT. Okay, so this basically usually happens in today's Soho environment. This is Soho. Just understand the concept only. That's all right. You don't have to understand it in the first go. You can take your time. ISP. Main thing is concept over here. Don't worry, you don't have to write anything as well. You can just repeat the video and watch it. So this is our LAN, okay? So why am I doing this? We basically show LAN like this, okay? It's very stupid of me, like, not to make a perfect picture, but still I will try, okay? So LAN, and then we have a PC over here. So 192.167.1.9, okay? And then you have a server over here, 88888, and port is 80. So in this case, what happens is that there will be two components to this thing. So it will have a IP and port. Similarly, source IP, and then it'll have a destination IP, and then a port as well, okay? So what happens is that basically this side, the server thing, is basically mostly fixed, okay? It's fixed. So if you see over here, it's Google's IP. 80 is fixed, right? That is for HTTP, okay? 80 port is for HTTP. So similarly, you have different things for FTP, file transfer, and then you have different things for mail, okay? So you have like different things for HTTPS. So in our router, what happens is that, so suppose you open a browser. Suppose you open a Chrome. You open Facebook. What happens? you will be assigned a particular port, okay, 1.9. Suppose your port is 6500, okay. So what happens is that so on this particular IP a port is opened. So what are the ports? So the ports are 121023 is basically reserved, and then 1024 to 65,535. okay, you don't have to remember, but it's around 65,000 something, okay. These are for other purposes, okay. These are the ports that is basically used by your system, okay. This the second one, these ones are used by your system. So our port that is currently valid is, or that is open, or whichever is currently available, is 6500. So your PC will basically use this particular port and then send all the traffic all the way to the router first of all, and then what happens, a network address translation happens over here, and then what this thing will do, you will have a public IP. So this will basically translate this private IP into a public IP. You might say like 27.19.2.3, and then it will assign a port to it as well, okay. So similarly, when the traffic, when it reaches all the way, okay, it sees the traffic and then it says, okay, I have the IP is this, the thing is this, port is this, okay, my port is it's requesting for this particular port, so it will allow the traffic to flow through it, and then the server will again serve some things, and then after that the packet will just travel over the ISP and then reach the router again. And then what will be the destination again? So the source would be this, and then our destination would be this, okay, with the port as well. Destination port is this. So the router, what will it do? So if you only had like this part, right, let's say like if you only had like, if this particular Google server like only recognizes the IP only, not the port, what will happen? The traffic will flow till the router, but now what, where will it go? So even though if it where will it go, right? So even though if it can like send it to your system, which application, right? The port also defines the applications, okay, the application as well. So suppose you have a Facebook opened in it in one tab, and then you have another Facebook opened in another tab. For each tab you will have a different port, okay. So see, it's 6501. So in this way, port helps us to basically manage the traffic as well, along with how we can basically it will help the router identify where to send that particular packet to, or which application or whatever service that it's running on the network, and then where to send it, okay. It's basically a identifier or additional identifier along with the IP, okay. So how many services that you can take concurrently? It's 1024 to 65,535. These are the number of services that you can actually take, okay. So every tab that you open up a new port. I will show it to you. CMD, right, let's go to our command prompt, netstat. If I just do netstat, see over here it's local address, and then blah blah thing is being opened. So my IP address is over here, this is like 56 something something, and then the foreign address is this, so it's HTTPS, which is 443, right? So same thing again. So see the new tab, another tab is open over here. So it might not be in like chronological order, like it might not be in a order, but it will basically be using whatever is available from 1024 to 65,535. I might be wrong in this particular thing. It's 65,000, but I'm not quite sure about 65,500 something, but just remember the concept only, okay. Not necessary to see. Again another port is open, but this is using for another IP, and then again for HTTPS, okay. So as you can see, different port for different application. All this different port represents a different applications within my system. Okay, so similarly IPv6 as well, same thing. And then Stack Overflow, HTTPS, right? So I'm accessing some things from Stack Overflow. It's open in my browser. If you see over here, I had it open, I guess. Yeah, I'm looking over here, right? That's where it is from. Similarly, I have like many things running around. So basically it's just defining like my source port only. Okay, so that's only my systems thingy. And then what happens once this IP travels all the way over here, it will be translated to something like let's say 172.19.10.5. suppose this is my public IP, right? And then it will translate it. This 172.167.1.9 will be translated to this particular public IP, and it will also assign us another port to it, whatever is available on the router. Okay, it must not be the same thing. It might be different port. That's very important. Everyone gets confused over here. Even I used to be very confused. Okay, so so whatever port is available on this particular router, that is assigned. So in this case as well, it's random. In this case as well, it is random. Okay, so it might be like 7500, and then all the way the traffic flows all the way to Google. It will see like the router will remember like, okay, this is the source, and then after that it will basically send the data inside, and then a data will come back out of it, and then after that it will again flow to ISP, and then it will come to our router. But what will be the destination from here? From here our source will be this, and then the destination would be this particular IP, right? And then it will travel all the way over here. And then if there is no NAT, right? Suppose there is no NAT, then what will happen? The traffic will be just dropped over here, because you don't have a NAT table, and then you don't know like this particular route is directly connected within your router, right? So a NAT, what will it do? It will basically translate this public IP into a private IP, and also it will translate the IP along with the port number. Okay, it will remember the information. Okay, so and then after that it will send it. Okay, after that the router will send it to a respective system, and within the system as well it will send it to the particular application. Like suppose you might be browsing like some kind of home, right? In this tab you might be browsing like your profile. So basically the traffic will also segregate itself. Okay, so if you have a lane over here, and then you have like two different stuff over here on your way, so you have one data comes in, so you will basically send this over here, and then another to that particular thing. If you don't have the port, then what will happen? The traffic, the packet won't know where to go, right? So which house to go to. Okay, that's pretty much it, guys. It's pretty simple, right? Like in a static, what you do in case of static, what you do is that in case of static you have a NAT table, and then you map a private IP to a public IP, and any communication that takes outside of your router is always in public IP. The NAT happens on your router over here. So another thing, important thing, don't always think that the NAT always converts a private network into a public. No, it might also convert a private network into a private network. Okay, so you might have a LAN, right? So within your company, and then what happens? The traffic gets sent over here, and then you might have like different IP over here, different IP over here, a different network over here, right? And then what happens? A NAT happens over here, translates it to this particular IP, and then after that it's forwarded over here, and then again a translation happens, and then it comes down. Okay, so it's not always. NAT can also take place within two private networks. Okay, very important, crucial point, very crucial. Very crucial. Okay, let's move on. So another thing that I just wanted to revise to you all is dynamic, right? So what happens in dynamic net, whatever is available. So suppose you have a bunch of public IP over here, public IP 100.2.1.5. Similarly, you might have 1.6, 1.7, right? So your system, what does it do? So you have like different system like 10.2.3.5, right? 3.6, 3.7. So suppose this is being occupied by some kind of application. What happens is that it will take the another whichever is available, and then it will forward the traffic. Okay, so basically in this scenario, what happens is that you have a router over here, and then this is your destination. So what happens is that whichever is available, so the traffic flows all the way over here, and then it gets translated to whichever public IP that is available over here. Okay, and then that public IP basically takes the information to the another destination wherever it has to go. Okay, so suppose if this is occupied, this will be used, and then there will be a session for every net. Okay, every net will have a session. Similarly, if this 3.6 has to communicate with something to the outside world, it will basically take this particular IP, and then if this is available now if it is available, then 3.7 will take that particular IP. So this is like it usually happens in a Soho kind of environment, right? That's where it is basically used. In enterprise, what you will need a static IP on the both sides so that the communication is always there, whereas a dynamic, what happens, the IP changes frequently, changes automatically, or frequently whatever the pool there is, it will basically change it. Okay, so you might have a DHCP server which will basically manage all the IPs. Okay, so the concept is that. Okay, so it's very it's changing rapidly. So suppose you have like continuous communication, or you have like very important system which needs to be configured constantly, then it's very hard for any network admin to manage it, right? Similarly, in a net, what happens is that you have a router over here, you have a router over here, and then you have a LAN over here, you have a LAN over here, and then you have a ISP suppose in the middle. Let's just show something like long distance communication kind of symbol. And then what happens is that 192.165.2.9, right? So whenever you open an application, a new port gets opened. The port is always between 1024 to 65,535. Let's say 1025 is open, and then what happens, the information travels all the way to the router, and then the router will basically translate it, the private IP, to a public IP, and then it will basically be 170. It might be anything, right? What basically be anything? I can't really specify anything. So .2, and then it might assign any port. Okay, it just does not have to be 120, 1025, whatever port is available on this particular router. So between any number between 1024 to 65,535. Okay, so it might be 2000, that's the thingy, and then it might travel all the way to 8888888, and then let's say 443, Google's IP, right? That's our destination. And then what happens, the destination, when it replies back, it will reply to this particular IP, and then the public IP again, it has like different IP address, different port as well, right? Then it translates it to the thingy. So it just remembers the session of the NAT in its NAT table, which we will definitely be looking at in later videos. So what happens, it again translates it to a particular IP, and then from here what happens is you will basically be getting your information that you've requested from Google, okay, inside your application. Every tab that you open in a browser, every tab that you open in a browser, might be using Facebook, Instagram, so this might have like 1500, this might be 1600 port. Okay, so every tab might have a different port. Even though if it's Facebook only, it will have a different port to it. Okay, so what does this port basically do? It will basically help us to segregate the traffic to, or it will just help the router to like tell like where to go, right, which applications to send that particular packet to. Okay, that's pretty much the concept is. And then inside NAT is like this thing. So inside the router, like from here, if the thing is traveling, this is the inbound, right, this is the outbound, right, and then this is like inside NAT, and then this is like outside NAT. Okay, that's all you need to remember. Just understand the concept: static, dynamic, and pat. It's basically based on port. Dynamic is it changes frequently, whichever is available, it takes that particular IP and then travels to WAN. Okay, in static, what happens, everything is already defined. It's static, it's constant, it does not change, so it's very useful for different kind of communications. So it just depends on scenario. Most important thing, all you need to conclude is you can't really say this system or this system should use this kind of NAT. Okay, you can't really say. You need to look at the scenario. That's very important. You can't be using a static in a Soho environment. You can be using, but it's not required, right? Whereas in enterprise, you might not use dynamic because the IP is always changing. You just don't want to be telling other people, okay, my IP has changed again, change your IP, right? You can't be doing that. So it's not really possible to do so. So it just depends on the scenario. Okay, just remember the concepts. It's very easy. If you have any confusions regarding this particular topic, please do let me know. I'll definitely help you out. Until next time, take care.